X feed, and it's called TripoSR Demo. So what is it? Well, there's a bunch of different diffusionary tools out there, and there's one that I use in Comfy UI called 0123, which is really great at taking like one image and then allowing, you know, the magic of AI to figure out spatially how it should form around it. I still think it's wonderful magic. Anyway, if you do a comparison of what TripoSR can do, it's significantly more accurate and the resolution is way up there. So what I want to do today, I just want to show you what it is and kind of go through the steps quickly on how to install it. It does take a little bit of RAM, probably around 8 to 12 gig would do just fine. You're not doing a whole bunch of computation. But let me pop it up on the screen here, and you can see this is what it looks like. This is the Gradio, the graphic interface, and shout out to Consumption who actually fixed the Gradio for this, and I'll put his link in the description. But here are a few examples of what it can do. So it takes these images here, right? And then you determine whether you want the background to be replaced or how the depth of field is, how close to the front of the object, to the back of the object, to figure out how to spatially do it in 360 degrees. But these examples are pretty cool. A variety of different examples from simple to complex. I quite enjoy the cactus because it has so many different depths to recreate. So down here is a comparison. I think I mentioned Zero Shape, which is that 0123 used in Comfy UI. And it does do a good job, but this one just does it a little bit better. You can see the quantitative comparison, you know, from down here to up here. So Zero Shape is like down here in the 50, and we're up here past 0.65. So if you want to get started with this on your local machine, you're going to want to clone this repository. Let me see if I still have it up. I think I do. Bring it over here. All the way to the top. All right, so the first thing that I did, man, that's really tiny. I really need to invest in a way to zoom in. Let me see if I can zoom in like this. That did not work. I zoomed into the wrong thing. Can I zoom in here? Edit. No. All right. Hold on a second. Let me put this back to what it was. All right. So if you know anything about Git repos, what you need to do first is find a hard drive space that if it's a solid state drive, that's the best drive to use. If it's not, no worries. Just make sure that the name of the drive doesn't have any spaces in it. Python does not like any kind of spaces in the directory paths. So that being said, I have this saved on gen_AI_app_builds. So you can use dashes or underscores. That's fine, just no spaces. So to start the process, I go in there and I do a git clone of the Git repository. And what that does is it clones all the necessary files into that directory. Now, what I'm going to do next is super important. I'm going to create a virtual environment for this repo. But instead of the traditional env environment, I'm going to do a virtual env environment. And there's something that has to do with the particulars of this repo that requires you do python-m virtual env space env. So you have to create the virtual environment in that fashion. After you've done that, you need to activate that virtual environment. So we're going to do that in a Windows environment. We're going to do that by typing /env/scripts/activate. And you're going to know that you're in your virtual environment because you're going to see this env here in parentheses. Now, the next step, if you follow the directions here, you can see that it wants you to install the appropriate PyTorch. So if you're on a Windows, if you're in Windows, the way that I did it was I went to PTorch, okay, and I went down to here and I selected all of these different areas here. So I went to stable builds. I'm in Windows. I'm using Python, so I'm going to use PIP. Python is the language. CUDA is, if you have a NVIDIA card, CUDA is, number one. You're going to want to use, I use 11.8, CUDA 12.1. There are some incompatibilities sometimes with some Stable Diffusion code, so I keep it safe. I do 11.8. If you don't have NVIDIA, you might want to use CPU. CPU is much more of a slow kind of process, but it's still doable. You can still create these images, and then simply you just copy and paste this command back into your command at the command prompt. After you do that, it's going to go through. It's going to install PyTorch into your virtual environment, all the files that you need. And then after that finishes, it took about 5 minutes to get through all of those files. The next thing you want to do is install the requirements that are necessary to run this repository. So you type or copy and paste pip install -r requirements.txt. Now, what that's going to do is it's going to go through and pick all the requirements necessary for this specific repository. Again, it's going to take some time. It's going to go through and install all of those requirements. It took about 5-6 minutes to do all of that. Almost to the finish line. So after all of that is installed, you're going to install the graphic interface, which is the Gradio. So pip install Gradio. It'll then start to download all of that information. And we're 95% there. After that is done, we're going to run it. So after you've gotten to this point, you type in Python gradio_app.py. Now, important to note that when you run that command, there's going to be nothing's going to happen for like 60 seconds. And those 60 seconds are going to feel like 5 minutes, right? But wait the 120 seconds, and what you're going to see is going to now download the model necessary to run this application. And then right after it's done, it'll prompt you with a local address that you can run to then start playing around with this repository. So let's fire up TripoSR, and this is what we got. So what you're looking at here is one of the examples that they provide. And I'm going to click on this burger down here. So you can see it's just a simple, it looks like a 512 by 512 image of a burger. It looks pretty realistic. And then it has two simple options. One is remove background, and the other is the foreground ratio. So the foreground ratio, like I said, you can kind of play with it to improve the results. Basically, it's how much information you're giving the application to figure out what the 360 degrees is going to look like. So I'm going to keep it at 0.8. I'm going to hit generate. Now I have a RTX 3090 with 24 gig of RAM, so mine's going to be like super quick. But be patient. This is like between 6 and 12 gig of RAM, so I'm going to say mostly all video cards will be able to handle that. So that took literally like a second to do. Now what we can do is we can hold down the left mouse button, and you can see we can rotate around this image. And I think it's pretty fantastic, just as sort of a quick 3D capture. Even like the little sprout on the top is 3D, which I think is amazing. Let's try another one. Let's try this fox. Looks like it's in the poly form. And here we go. I mean, you know what? One of the ones that really blew my mind is this guy. Okay, so this is a stuffed animal. You're looking straight at the stuffed animal, right? Now, the computers will know what the stuffed animal is, but somehow, in the realm of amazingness, it knows that it's a dinosaur. And I know that it knows it's a dinosaur because when I go to turn it around, oh, now it's gonna call me out. See, this is where the foreground ratio comes in. So let's knock this down to like 6 and regenerate. Because the first time I did this, it had a tail, just like that, which I think is pretty amazing. Taking just a front-facing image of a stuffed animal and then having the computer and this program understand that it is a dinosaur and provide a tail, and not just a tail, but a tail and a butt and all like the leg. It just blows my mind. Let's try another one. Okay, this is interesting. So let's do looks like a isometric image of a house architecture. So let's generate this, and let's see how well it figures out what the back of this house looks like. I'm not really digging the resolution, but yeah, I'm not really okay. So let's mess around with this a little bit. Let's see what 1 does for us. All right, so 1 is going to. Yeah, I'm not really digging the resolution on the on this building is not really that great. Let's go the other direction. Let's try like a 5.5. Not really happy all around. But again, this is supposed to be just like a quick 3D rendering, or a quick 360-degree rendering. That's really all I wanted to show you guys. Again, shout out to Consumption for fixing the Grotto. The Grotto wasn't working for whatever reason. He went in there and messed with the code and fixed it. So if you guys have like 3-dimensional images that you just want to kind of visualize to see how it will look as in a 360-degree, look at that. I mean, I think that's really cool. Like, the computer figured out, what the back of the robot looks like. It actually got a nice oval shape for the head. The antennas are sticking out. Very cool stuff. And then you can just download it, just like that, as an object that you can put right into Blender. I'm glad I kind of mentioned that. It's very important. So you can download it directly as an object that you can throw in the Blender and mess with. So anyway, just want to do just a quick video on that. I hope you found it useful. I will put all the links in the description below, and I'm going to follow up with you guys on some other stuff that I just came across that's pretty fascinating, sort of in the Sora AI realm, in improving the animation using animated diff and a few other modules. But until then, thanks for watching, and I'll catch you guys later.